Hi guys! Welcome to topic 4. This topic is all about water, food production systems, and societies. In our first class today, we are going to do an introduction to water systems. So we're going to talk a little bit about water budgets in the world, and also a little bit about how water moves around in the world, and how humans impact the movement of water through different storages on our planet. So let's get started. The first thing that we're going to go over just briefly is Earth's water budget and the water cycle. So, about 70% of Earth's surface is water. Most of that water is salt water, which is bad news for us because it means that we do not have access to it for easy use. And most fresh water is in ice caps. So out of all of the available water on the planet, only about 3% of it is fresh, and only about 40% of that is sort of easily extractable as usable fresh water. All of this water moves through a system or a cycle with storages and flows, and you can see a picture of that here. So water that's in the oceans might condense into the atmosphere. Once it's been in the atmosphere, eventually it will fall as precipitation. It could either freeze or it could travel through a groundwater flow back into the ocean. And this movement of water goes around and around and around. Generally, water stays for the longest amount of time in the ocean and the shortest amount of time in the atmosphere. And we are going to talk a little bit about how humans impact that cycle. So there's 3 main things that people do that influence that movement of water through these different storages. The first is withdrawals, and this is getting to be an increasingly serious problem. This picture is a picture of the Aral Sea. And the Aral Sea is an area in the Middle East where there's a lot of cotton cultivation done. And you can see in this series of pictures what the Aral Sea, which is sort of misnamed as a sea, it's a very large inland lake, what it used to look like before cotton farming became popular in the area, and then what it looks like more recently. So there's a huge human impact on this storage of water, this surface water storage, because of withdrawals. We are taking water out of the Aral Sea in order to do crop cultivation. And that's making a big difference in how that water is flowing around in that environment and also on the people that live there. The second thing that we do that causes a big impact in the water cycle is we discharge things into water. A good example of this is the Ganges River basin in India. There's a lot of pollution in that water. So it would be a clean source of water as this river, this surface water storage flows through India, but all along the route, pollutants are being discharged, both through point source and non-point source pollution, into the river, and the result is water that is so dirty that it's basically unusable in an untreated form. So discharges have a huge impact on the water cycle because that water carries those pollutants with it for a long time as it moves through the water cycle. Polluted water that is evaporated up into the atmosphere results in polluted rain falling down over the land, and that's where we get things like acid rain. So that's a big deal. The last thing that we do is change the speed and direction of flow. And we do that through creating artificial channels and reservoirs and dams to try to control water flow, mostly for irrigation of crops. So those 3 things change the water flow pretty significantly on the surface of the planet, and you can see evidence of that in urbanization and flash flooding. This is getting to be an increasingly serious problem in our world. This is a picture of Buenos Aires in 2013 after the La Plata floods. What happened in Buenos Aires was they concreted over the surface of the city so rapidly that when water came in record amounts in 2013, there was nowhere for it to go, and this whole neighborhood in Buenos Aires flooded. And that's happening more and more as we are impacting water flow by changing, I'm going to go back for 1 second, changing the direction of the flow and the speed of the flow through different areas. So that's a good real world example of that happening. Let's move forward now and talk a little bit about how water moves around the planet in the oceans, because so much of the water on our planet is in the oceans. And there's two ways that water in the oceans can move. The first is through surface currents, and that only accounts for about the top 400 feet of the oceans, but it basically blows water back and forth due to wind. The second is through thermohaline currents, temperature and salt-based deep water currents that are controlled by both the temperature and the density of the water. And these control climate and weather for our whole planet. And you can see in this picture some of the major thermohaline currents that exist on our planet. Generally, if you draw a line here at the equator, warm water that's been warmed through insulation flows away from the equator, cools down, and then due to that temperature differential, comes back up towards the equator. It gets heated up again. It gets heated up until it moves back south, and it forms these sort of cells of circulation of water. And the movement of water up and down in the oceans is super important to us because upwelling and downwelling of water is what moves around populations of fish. And we'll talk about that a little bit more when we talk about aquatic-based food production. But that's a significant thing to keep in mind. When we look at ocean-based water movement, there's one set of specific climate events that people talk about a lot, and it's worth checking in on them in this class. And that is the El Niño and La Niña isolations in the Pacific Ocean. If you want to watch a little video on this, there's a video linked here. If you can't get the link to work, you can Google Met Office El Niño, what is it? And this is a great informational video about how this current system works. But the basic idea is this. In the Pacific Ocean, normal conditions, because of wind and surface circulation, move water from the west coast of the United States to the east coast of Asia. As that water moves, deep cold water moves up to replace the water that's leaving the coast of the Americas, and this upwelling brings with it fish population, so this is great for fishing. And then over here, as the warm water hits this body of land, it gets sent down, cools off, and this creates a circulation cell. In an El Niño year, the wind that causes this to happen weakens. And instead of this weather system happening over the coast of Asia, it happens sort of in the middle of the ocean. So the weather system moves here, and these two weather cells get smaller. This results in a couple of things. There's not as much upwelling on this west coast of the Americas, and that's bad for the fishing industry. And since this cell is smaller, there's more extreme weather events happening on the coast of Asia. And that's bad for all of the food production in Asia because it leads to a ton of flooding. So that's an El Niño event. Normally after an El Niño event, in an attempt to correct itself and bring itself back into a state of equilibrium, the climate cycle moves into really strong trade winds and strong water currents pushing this way, and we call that La Niña. And in that event, there's extreme weather over the coast of Asia, and it's upwelling for fish over here is okay, but it results usually in sort of like a dry environment over the coast of the Americas, so that's not very good in terms of water, general water availability in the world. So in terms of implications for sudden changes in ocean circulation, this is a good small-scale example. And this is a problem that we're going to have to consider globally as ocean temperatures continue to change due to global warming. Because as we talked about in thermohaline circulation, that's all controlled by temperature. So if the temperature of this whole system increases, you're going to see more and more energy here and more water movement and more storm systems and more changes in ocean circulation. And none of that is great in terms of its environmental impacts. But for now, we are just going to move into your homework. So if you're following along in the textbook, you should read pages 198 to 206 in the Oxford Press Environmental Systems and Societies book. And you should try these 2 comprehension questions. So you are being asked to do a calculation. This gives you storages of water in the water cycle and the water volume in each. You need to calculate the percentage of water that exists in each storage and write it in. On your homework sheet, there's an extra column that you can write that in. And then also discuss with a named example 1 human activity that would impact the water cycle. So give those a try, and when you are ready, you can go over your answers in the review video. I'll see you there.